Today's lesson deals with ocean currents. Before we can talk about ocean currents, though, we must understand the three ways that heat is transferred to the earth and on the earth. The first type of heat transfer is conduction. Conduction is the transfer of heat when two objects are in contact with each other. For example, the pot on this stove is in contact with the stove, and so the heat is transferred. And the hand is using a hot pad, so because if you touch the pot without the hot pad, then heat would be directly conducted from the pot to your hand, as you all know. So conduction, again, is transfer of heat when two objects are in contact with one another. The second type of heat transfer is convection. Convection is the transfer of heat in a fluid. And a fluid can be a gas, it can be a liquid, and even sometimes can be a solid. If we look at this diagram, what we need to understand is that things that are hotter generally are less dense. Think about a pot on a stove. The heat is being transferred from the stove to the pot due to conduction. But then if we have water in that pot, the water at the bottom of the pot, heat is transferred from the pot to the water through conduction. But as the water at the bottom of the pot gets hot, it gets less dense. And so less dense materials will rise to the surface, and the cooler, more dense water at the top of the surface in the pot will sink to the bottom. It then will get hot, and the water at the top will cool some, becoming more dense. So this hot water will rise up, and the cooler water at the top will go down. This is convection. Convection happens in our atmosphere. Warm air near the surface rises, and cool air aloft sinks to take its place. This happens in the mantle of the earth, where magma, the warmer magma, is closer to the center of the earth, and it rises very slowly, and the cooler magma, closer to the earth's crust, sinks to take its place. That happens very slowly because the mantle is considered a solid. It's a solid that has the ability to flow like a liquid. And the word for that is plasticity. In the oceans, the water is generally heated from the sun. And we'll talk about how it's heated from the sun in just a minute. But the water in the oceans is heated from the sun and is moved around by wind and such as that. And over time, convection can be started in the ocean, and this can help to cause ocean currents. And the third way that heat is transferred is through radiation. And for the earth, that radiation is radiation from the sun in the form of electromagnetic waves. The radiation from the sun hits the earth, whether it be ocean or land. Some of that heat is absorbed. Some of that heat is actually reflected from the surface. But that is absorbed is heat transfer, and that is being reflected is being radiated back into our atmosphere and back into space. So radiation is the transfer of heat through waves. And that brings us to ocean currents, which are caused by the unequal heating of the earth. The source of almost all Earth's heat energy is the sun. The sun gives off its heat in the form of electromagnetic radiation, as you know. which travels through space. About 45% of the sun's radiation is actually absorbed by the oceans and the land. The remaining 55% is sent back into space. It's reflected. The sun's heat is distributed throughout the atmosphere, land, and the oceans by radiation, conduction, and convection, providing the energy to make weather. Unequal heating of the Earth occurs due to the Earth's tilt. Areas closer to the poles receive indirect rays and have cooler temperatures. The sun's rays are more direct at the equator, resulting in warmer temperatures. Temperatures get cooler as you move away from the equator toward either of the poles. When water is heated, it expands and its density decreases. Less dense matter tends to rise in a fluid such as ocean water. As the area around the equator warms, convection occurs in the oceans, distributing the heat. Global winds blowing across the ocean transfer energy to the ocean surface. The winds drag along the surface of the ocean, creating currents that move along the surface of the ocean. Ocean surface currents are caused mainly by global winds. The ocean surface currents move in a curved pattern because of the Earth's rotation. It's called the Coriolis effect. Other factors, including the temperature of the ocean, influence the complex spirals of ocean currents. And keep in mind that ocean currents that are moving from the poles will be cooler or cold currents. And those currents that are formed at the equator and moving either north or south will be warm currents. So we can actually have cold ocean currents in the equatorial regions because they are currents that are moving down from the poles. And we can have warmer currents in the polar regions because those currents are moving from the equator up towards the poles. So you can have relatively warm currents at the poles and relatively cold currents at the equator, depending on where those currents originated. So to review, the three types of heat transfer are conduction, when two objects come in contact with another, radiation, where energy is radiated from the sun and absorbed by the earth, and convection, the movement in a fluid due to differences in density, more warm fluid being less dense and rising, and cooler fluids being more dense and sinking to take the place of the warm that has risen. These three things cause, in the atmosphere of our Earth, winds on a local basis and on a global basis. The oceans are heated by radiation from the sun. That water is moved around due to wind patterns and through convection not only in the atmosphere but in the ocean as well, creating the ocean currents.